Okay, so we are talking about isosceles and equilateral triangles. So the first thing I want you to do is write this. Currently it's also in my whiteboard, but I wanted to have y'all write it down. Equilateral triangles would be in the middle, like this, where you have 3 sides equal and 3 angles equal. And we just talked about them all being 60 degrees. Isosceles would be outside of that with 2 sides equal. And you can draw your circle. Technically it's 2 or more sides, but we really just say 2. Like 2 sides equal and 2 angles equal. Then over here we're going to have our right angles and right triangles, where you'd have a squared plus b squared equals c squared. So for example, 3, 4, 5, 6, 8, 10, anything where the Pythagorean theorem holds. And in this part right here, this would be your right isosceles, isosceles, which is when it's 45, 45, 90. So this middle part is the RI part, or right isosceles part, and it's 45, 45, 90. Okay, so make sure you get that so you can use that on your test. Oh, and then also any triangle would be outside of that. So any sort of triangle, like scalene would be a good example. I'm not going to label where acute and obtuse would be, because you can have some acute angles that are isosceles, but you can't have any obtuse angles, and I just want to keep this simple. I don't want to make it more complicated. Okay, so now let's work on the rest of the definition. This says the base is a side that's included. So basically, if these are your angles, then this is the base. And base angles are touching the base. And so those two are equal. The definition would be the 2 congruent angles, of an isosceles triangle. Just going to put the triangle symbol. The 2 congruent angles of an isosceles triangle. The next one is the definition of corollary, which is a theorem that can be easily proven, by another theorem. So the corollary to the isosceles triangle theorem, which had 2 sides equal, was this one, which is equilateral, which has 3 sides equal. So a corollary would be something very, very similar and easily proven. Okay, the next one is the equiangular triangle, and so that's when you have all angles 60, and they want you to draw a figure for this, and then just mark all these with the same angle mark. So if you want to do all of them with 1 mark or all of them with 2 marks, that's fine, and they're 60 degrees. The next one is the isosceles triangle, and there's the picture. So this is a triangle with 2 congruent sides. A triangle with two congruent sides. The next one is about legs. The legs are the two congruent sides. So basically you could copy this exact same figure that's above it and call this leg 1 and this leg 2. And we know they're equal. And then your vertex angle is the angle formed by the legs of an isosceles triangle. So in the case where you have these two equal, then the vertex angle would be at the top. I'm going to mark the vertex angle with 2 marks, and I'm going to mark the base angles with 1 mark. So there's your vertex angle, and there's your base angles. Any questions on the definitions? So there's only one vertex angle but 2 base angles. If it were rotated different, it could be like this, where these two are equal, so this one would be your vertex. So that's just if it's turned to the side. Okay, the next page has some of our notes in here that you could refer to. This is about showing it's an isosceles triangle, so you have a perpendicular bisector. This is just showing you about equilateral and equiangular, and we had an example like this in the notes also. And then let's work on our example. I guess here's one more, or finishing that problem. Okay, so now we're on the exercises. On this one it says complete the statement and explain why it's true. So first off we have EAB. EAB is right there. So on this, explain that it's true, that's why you need to show work. Show a little bit of work. So to get that angle, we'd have to figure out, is the 40 a base angle? Or is it a vertex angle? Is this 40 a base angle or a vertex angle? So since your legs are here, it's a vertex angle. And since it's a vertex angle, then you basically do 180 minus 40 is 140, and then divide by 2 and you get 70. So this is 70 and this is 70. Any questions about that part? Okay, then this one says BCD, which is this angle, is equal to DBC, which is this angle. I need to mark them with 2 marks since I've already used 1 mark. That would also be equal to BDC, because this part is equilateral and equiangular. So we're going to say it's equal to BDC, or actually congruent, to BDC, which is equal to 60. So all three of those angles would be 60. By the way, since I'm doing that, let me also label ABE up here for this one. So both of those were 70. Okay, the next one for number 3 says FG is congruent to DF, which is also congruent to DG. And there's no number that we know about that. We just know the side is equal. Any questions? Okay. Number 4, determine the measure of the indicated angle. ACB is this one. Because it's equilateral, that makes this 60. Because it's 180 divided by 3. DCE would be this angle, and would this 50 be base or vertex? Yeah, vertex, very good. So because of that, then we go 180 minus 50, we get 130, and then divide by 2 and get 65. So DCE is equal to 65. The next one is BCD. BCD. I'm going to mark that with a red angle. Actually, just going to do that. BCD is this angle. So to get that, we're going to use the fact that angles add up to 180. It's not 180 in the triangle in this case, although that would be true, and same thing here. But it's basically adds to 180 because this makes a straight line. So basically, I'd like you to write angle ACB plus angle BCD plus angle DCE equals 180 because it's a straight line. ACB plus BCD plus DCE equals 180. Okay, so then we just add 60 and 65 together. That's 125. So then we just do 180 minus 125 and get 55. So that's what BCD is. Any questions? You basically got a 60-degree angle, and if this one's bigger than 60 by 5, then this one's got to be smaller than 60 by 5. Alright, then number 7, this is the algebra type question. You're given this is 110, and these two are the equal ones. So you do 180 minus 110 is 70, which makes both of these 35, because you're dividing by 2. And on this one, these two sides are equal, which makes these two angles equal. And the first thing we do is we indicate this as a linear pair. Y'all remember a linear pair is two angles that add up to 180 that share a common side. So this would do 180 minus 115, which is 65. So just put 65 there and there. and then 65 plus 65 is 130. 180 minus 130 is 50. So y is 50. And we already got x is 65. Okay, this will be our last one for the day, I think. So it says exterior angle is 140. So let's put 140 there, which makes this 40 and this 40. And so this other one has got to be 100. So it's not drawn to scale. So you get 40, 40, 100. And it would be the same thing if you did it on the left, but we need to do it on the top. So if we extend this line and make this 140, then this is 40. So then we subtract and divide by 2, so we get 70 and 70. So we get 40, 70, 70. This type problem we did before on a different lesson. Okay, so that is the end of the reteaching. We'll continue tomorrow on the practice. There's a Form K, which we're going to do, and there's a Form G, which you do.